All right, we're moving right along verifying identities. And now we're going to verify that the secant of theta plus 1 times the cosecant of theta minus the cotangent of theta is equal to tangent of theta. What I'm going to do first before I do anything is I'm going to do, because this is really just calling that I multiply these two expressions. So before I do anything, I'm going to multiply these two expressions so I can have one big expression. Now notice when I do that, I have to use my, I call it a song and dance or distributive property where you have to multiply everything into everything. So I am going to multiply secant of theta times cosecant of theta. So that would give me secant of theta, cosecant of theta. Then I'm going to multiply secant of theta times a negative cotangent. So that would be minus secant of theta times cotangent of theta. Then I'm going to multiply a 1 times cosecant of theta. And that's just, of course, going to be plus cosecant of theta. And then I'll multiply 1 times a negative cotangent of theta. That's just negative or minus cotangent of theta. Now all this equals to tangential of theta. Okay, now I'm going to rewrite things in terms of sines and cosines. And I'm looking to see if anything cancels, but nothing cancels. So let's go ahead and move forward to rewriting everything in terms of sines and cosines. Look at this, a secant of theta times the cosecant of theta. Well, secant is 1 over cosine, and cosecant is 1 over sine of theta. So I know that this is just going to be a 1 over the cosine of theta times the sine of theta, right? Because they're being multiplied. Minus, same thing is happening here, except we got cotangent. Secant is 1 over cosine. So I got a cosine down here and a 1 in the numerator. But that 1 in the numerator is going to be times the cotangent. Cotangent is the cosine over sine. So that means in the numerator, I'll have 1 times cosine or cosine of theta. The denominator, I'll have another sine from that tangent. So I would have cosine of theta over cosine of theta times sine of theta. Secant here, cotangent here. Plus cosecant of theta. Well, that is just 1 over sine. So I'd have 1 over sine theta. Minus cotangent of theta. Again, that's just cosine of theta over sine theta. And this is equal to the tangent of theta. And let's go ahead and put this expression to the left. Let's just put it in terms of one big whole fraction. And if I look into each one of these denominators, I notice my common denominator is obviously going to be cosine of theta times sine of theta. So that's going to be our common denominator. We got a cosine of theta times a sine of theta, which means for the first two fractions, since they already have that denominator, I can just bring those numerators down. So I know in the numerator I'll have a 1 minus, and over here I'll have that cosine of theta. I can bring it down because they already have the denominator of cosine of theta, sine of theta. Now the other two do not. So over this fraction, 1 over sine of theta, I have to multiply it by the cosine of theta that it's missing. So I'm going to multiply both top and bottom by cosine of theta. Okay, I'm trying to write it and not be too messy. All right, so that means we already got the denominator taken care of, cosine of theta times sine, but the numerator would turn into a 1 times cosine of theta, which is just cosine of theta. So I would have a plus cosine of theta. Over here, I got to multiply this by the cosine of theta that it is missing. So I got to multiply top and bottom by cosine of theta as well. again, we got the denominator squared away, but the numerator is going to be a cosine of theta times a cosine of theta, or cosine squared theta. So we'd have minus cosine squared theta that we're bringing down. At this point, I'm going to go ahead and rewrite the other side of this expression as sine of theta over cosine of theta, because we know that's what tangent equals. It's just sine of theta over cosine of theta. Okay, let's see if we can get all of this stuff looking the same. I notice in the numerator, cosines are going to cancel out. So I'm just left with a 1 minus cosine squared theta over cosine of theta sine theta. And if I think about it, 1 minus cosine squared theta, I know that equals sine squared theta. A 1 minus cosine squared theta is just sine squared theta. And that's over cosine of theta, sine of theta. Okay, and that should be equal to sine of theta over cosine of theta. Now, if we look at this, guys, sine squared theta at the top is going to cancel this sine at the bottom. So one of the signs will cancel, and in the numerator, I'll just have a sine of theta over a cosine of theta. I have the left looking like the right. We verified this expression.